All right, this video is about rational functions also, but we're going to talk about crossing the horizontal asymptote. All right, that sounds strange, but it happens. So what you need to know is vertical asymptotes will never ever be crossed, okay? That you can bank on. It will never be crossed. However, horizontal asymptotes are sometimes crossed by the function when you graph it. Like if you have a horizontal, sometimes that curve will cross it, and sometimes it won't. And so how do you know? Well, there is a way you can test it and find out. And if you test it, you'll find out exactly where it does cross. In fact, you'll get an XY coordinate to know, hey, look, it crosses that asymptote right there. Yet another clue to the graph. So here's what you do. You set the horizontal asymptote that you found equal to the original function. If it can be solved, then that's the point that the horizontal asymptote crosses the line. If it cannot be solved, then the function does not cross that asymptote. Okay? What I mean by can it be solved? Can you get the two sides of the equation to equal one another? All right? So let's try this. Let's look at this example, okay? So for this, really all we need to focus on is what is the horizontal asymptote. So if we use Bobbio-Botno eats DC, remember Bobbio, or what we're looking at is the highest exponent on top versus one on bottom. Well, there is no exponent on top, but there is one on bottom. So it is bigger on bottom, which makes this a Bobbio, which means the horizontal asymptote is y equals 0. Remember, that's what yo means, y equals 0. So what I do now is I take that 0, set it equal to the original equation, and I'm going to try to solve this and see if it turns out to be a true mathematical statement. Well, if I cross multiply, 0 times x minus 4 equals negative 3 times 1. Well, that's 0 equals negative 3. Is that a true statement? No, that means it does not cross. Okay, let's try this one. All right, if I do Bobbio-Botno eats DC to find the horizontal asymptote here, I look, the exponents are the same, so I divide the coefficient, so it's an eats DC, exponents are the same, divide the coefficient, so I have 3 over 1, so the asymptote is y equals 3. Now I set the 3 equal to the equation, and see if I can solve it. Okay, so cross multiply. Distribute the 3. All right. So notice I have 3x squared on both sides of the equation. All right, I can subtract them from one side, but they're going to go away from both sides, right? So what I have is a statement that says 9 equals 11. That's not true. So this one does not cross. Okay, so I just want to kind of give you an idea of the process. If they do equal, then it will cross, and we'll talk about that. Okay, so let's try another one. All right, this one we're going to run through all the steps that we've been doing because we're going to graph it. All right, so let's find out, is there a hole? So I need to factor the top. Well, that's done. The bottom, if I factor it, is x plus 5, x minus 4. I have no factors in common, so I have no holes. So I say none. X-intercept, take the numerator, set it equal to 0, solve it. So I have a negative 3, 0 as my intercept. Vertical asymptote, I set the factors in the bottom, the denominator equal to 0, and solve those. So x is negative 5, x is positive 4. So I have 2. All right, horizontal asymptote. Okay, Bobbio-Botno eats DC. Look at the highest exponent on the top versus the highest exponent on the bottom. The bigger one's on the bottom, right? So that's Bobbio. Big on bottom, then y equals 0. That's what Bobbio means. So y equals 0 is my horizontal asymptote. Now I have to decide, does it cross this asymptote? So I set 0, since that's the horizontal asymptote, equal to x plus 3 divided by x squared plus x minus 20. All right, Put that over 1, cross multiply. Well, 0 times anything is 0. 1 times x plus 3 is x plus 3, right? So when I solve this, I get, if I subtract 3, x equals negative 3. All right? So there's my x-coordinate. What is the y-coordinate? Well, the y-coordinate was the y equals 0, right? Y equals 0. That's what we put in right there. So it does cross the x, or it does cross the horizontal asymptote, and where? At negative 3, 0. So the x-intercept is actually on the asymptote. That can happen. All right? So what about the y-intercept? Lastly, y-intercept, remember you take your equation and plug in zeros everywhere there's an x and solve it. So I do 0 plus 3 over 0 squared plus 0 minus 20, which gives me 3 over negative 20. All right, so my y-intercept is 0, negative 3/20. So that's just barely under the axis. So let's graph this guy. All right. So let's see. Vertical asymptote at negative 5. Vertical asymptote at positive 4. Horizontal asymptote at y equals 0. Okay. X-intercept is at negative 3, 0. Okay. Right here, it sits on the asymptote, that horizontal asymptote. So I know it crosses there. And let's see what happens from there. What's it doing? And y-intercept is at 0, negative 3/20. So it's 0, negative 3/20 is just under this axis, right? So it's doing this business. Okay? And what's it doing here? Well, look at the multiplicity at x minus, or at the x-intercept. Okay? Look at your equation. X-intercept has a multiplicity of 1, right? That means the line's going through it. It's not bouncing off, so it's going through, so it's going to curve up. All right? So we've established what's happening in the middle part of our graph. So what's happening on the left side of this asymptote? So if this is negative 5, let's plug in a negative 6 into our equation and see what's going on. If I do that, I get negative 6 plus 3 over negative 6 squared, which would be 36, minus 6 minus 20. So it's negative 3 over 36 minus 6 is 30, minus 20 is 10. So 3/10. So I have negative 6 and negative 3/10. That's a point on the graph. So that's down here. Okay? And we know it doesn't cross this horizontal asymptote anymore. We found the one place. So it's coming, doing this thing. What about on the far right over here? Okay, this was f of negative 6. Let's find out what's happening in, if this is 4, let's use x is 5. So I'm going to scooch up here and make some room. F of 5 would be 5 plus 3, which is 8, over 25 plus 5 minus 20. Well, that's 30 minus 20, which is 10. So I have a point at 5 and 8/10. Right? That's not quite 1. So at 5, it's down here. It's, or no, 8/10 is positive. So it's going to be up here, but it's going to be under this. It's going to be just about, remember this asymptote right here is at 0? So 8/10 is above it. Just a little bit, but it's doing this business. It's not crossing it, it's just above it. So there's my rational function. You got 3 sections, so it's a little more complex. Let's try another one. All right, same song, second verse. We're going to factor, factor, factor. Let's factor the top. I get x plus 3, x minus 1 on top, x minus 2, x plus 2 on the bottom. Okay, first, I look for holes. Do I have any holes? No, there are no common factors, so no on that. X-intercepts, all right, take the top, set each one equal to 0, and solve it. So this x is a negative 3, this one is a 1. So I have a negative 3, 0, and a 1, 0. 2 x-intercepts. Vertical asymptotes. Set the bottom equal to 0. So I have x minus 2 equals 0, x plus 2 equals 0. Don't confuse yourself. Okay, this is y-intercepts. I'm sorry, this is vertical asymptotes. So solve it. X is going to be 2. X is negative 2. Now, horizontal asymptotes. Fabio Bottom eats DC. Look back at the standard form of the equation where it's all multiplied out. Highest exponents on top is x squared, on bottom x squared. So this is an eats DC. Exponents are the same. Divide the coefficients. So it's 1 divided by 1. So y equals 1. All right, now we have to decide, does it cross this asymptote? So I set the 1 equal to the equation at hand. 1 over 1 is the same, so I do that. And I can cross multiply. So I'll have x squared minus 4, is it equal to x squared minus 2x, or plus 2x minus 3. So if I subtract x squared from both sides, those are subtracted out of the equation. So I have negative 4 equals 2x minus 3. I'm going to add 3 to both sides. I get negative, add 3 to both sides, I get negative 1. That's a 1. Equals 2x. Divide by 2. So x is 1/2, negative 1/2. So my point is x is negative 1/2. And what's the y value? Well, it was a 1. So this is a yes. And where does it cross? At negative 1/2, 1. Alrighty? So now y-intercepts. Remember to take the original equation. Let's plug in zeros everywhere there's an x. So I have 0 plus 2 times 0 minus 3 over 0 squared minus 4. So this is y-intercepts up here. Okay? So I get negative 3 over negative 4, which is positive 3/4. Okay? So my y-intercept is 0, 3/4. Now let's graph this guy. All right, I have vertical asymptotes at 2 and at negative 2. And I have a horizontal asymptote at y equals 1. Okay. X-intercepts at negative 3, 0, and at 1, 0. Okay. And a y-intercept at 0, 1, or 0, 3/4. It's not quite, it's right there. 0, 3/4. Now, let's use our clues to figure out what's going on. All right. We know, we didn't put in our crossing point. Our crossing point is going to happen at negative 1/2 and at 1. So it crosses this horizontal asymptote right there. So we get a good idea of what's happening. This curve is going to go up, and this one crosses and goes down. Okay. Now over here on the far left, look at this. We know this curve is not going to cross the horizontal asymptote because that's not a crossing point. It's going to hug the asymptotes. Now over on the right, we don't know. We need to pick a point. So we know the asymptote's at 2. So let's use a 3. Okay, so what is f of 3? So I put it in. 3 squared plus 6 minus 3 over 3 squared minus 4. So let's figure this out. 9 plus 6 minus 3 over 9 minus 4. So that's 15 minus 3 is 12. 9 minus 4 is 5. So that gives me a point. If x is 3, then y is 12/5. So what is that? Well, that's 2 and 2/5. So it's between 2 and 3. That's what you need to know. So where x is 3, it's between 2 and 3. So it's up here. It's positive. That's the big picture. Okay? All right, so there's your rational function. It's getting a little more complex, but you can do this. Okay? Now you try one on your own, and we'll see how you do in class.